Okay, thank you, Pete. I appreciate it. It's good to be here again in front of all of you, and I hope remember you got lots of questions. Type them in. We'll get answers for them right there. Rusty, Pete, and Dan are all going to be on questions while we're going through, and I've tried to lay this out as much of the logical order as I can for you. So we have a few acknowledgments here. The acknowledgments are for all of the videos, the pictures, and other things that we potentially did not capture ourselves with the Alliance. One of my favorite things ever is to get out into that job and that project site and go in and actually capture the ongoings of the construction crew as we go through it. Definitely don't get to do it as much as I would hope. Obviously, I'm stuck indoors in a webinar today, but that's for all of our benefit. Is you ask lots of great questions and listen for us when we talk about wonderful things such as trenchless technologies and pipe bursting to try to make it so you can rehabilitate that infrastructure. Lord knows we got lots of need out there for infrastructure rehab. So here's pipe bursting as a definition. Certainly a lot of words on this slide, but the three primary things that we're doing during pipe bursting are going to be the existing pipe is pipe is fractured and split. So that's that existing pipe. We are pushing out to create a temporary soil cavity to receive that replacement pipe. And then we are pulling back that replacement pipe as we go through. So those three things happen simultaneously, and the only difference between the technologies here become pneumatic and static pipe bursting are the mechanisms as to which we provide that force to go through. So pipe bursting is the only trenchless technology rehabilitation method that can put back a larger OD than the existing pipe that we have. So this isn't new installation of a pipe. This is a rehabilitation of that existing pipe. Pneumatic pipe bursting uses a constant tension winch that pulls and aligns an expander head and an impact hammer to the face of the existing pipe. Then that impact hammer is powered by an air compressor delivered compressed air through a hose within that production pipeline. Then that pipe bursting process just inches along and breaks that existing pipe as we go through. So pneumatic pipe bursting only uses high density polyethylene and is primarily for gravity sewers, for asbestos cement, vitrified clay pipe, and cast iron pipe. Static pipe bursting can install any type of pipe as a production pipeline, but also can cut through other pipelines by a series of cutting attachments in front of the expander head. Now, the way that the energy is delivered between these two types is different. In static pipe bursting, we're going to put either a cable or a rod, a hardened rod, through the existing pipe, attached to that pulling expander head and any type of cutting equipment that we have, and then pull it through that existing pipeline. It'll be attached, of course, to the production pipeline part with the expander head as it goes through. And that process then will do the same thing, which is fracture that existing pipe, three primary things, create a temporary soil cavity, and then pull that production pipeline back through. So if we look at pneumatic pipe bursting, here you're going to see the constant tension winch and everything that's laid out in front of you. We do need excavations. It's called a trenchless technology, but it's not entirely void of excavation. We're looking 85% less excavation in some instances. Each of the service connections do have to be excavated externally to be able to reinstate those. And we are happy to put back something very stout and stable of your service connection, either an electrofusion fitting, mechanical fitting, some type of socket or fusion itself through that service connection, because that'll stop any inflow and infiltration for gravity sewer. That water does run along pipelines and some cured-in-place pipeliners as well, and finds a way in. So we do have hard and fast connections through excavating and and restoring those. Here are some images of impact hammers. Now, when we get longer in format and our equipment gets bigger, now that's called a pilot that's out in front of this expander head as it moves through. Those apparatus can either be together or the expander head can simply slide on top of that pilot and change in size and dimension based on the existing pipeline that we have. So contractors that are going to be familiar with performing pipe bursting projects have a lot of these tools. They get a lot of wear and tear through them. They also are prepped for a lot of different ranges and sizes. And then also the manufacturers of the pipe bursting equipment maintain entire rental fleets that are very well maintained pieces of equipment that if you have a specialized job, you could pick up the phone and call, and they'd be happy to deliver you the rental of the equipment as we go through. In some instances, high-density polyethylene makes it very convenient to attach these expander heads directly to that HDPE. So what you're seeing here is an expander head that's simply drilled into the HDPE. And that drill, as we come through, that screw holds onto it, and that's more than enough to be able to keep that expander head on that high-density polyethylene. Then that piece is cut off before we're put into place. Yes, Pete.
So one of the things when I was learning about this business, Alan, that I found confusing was they call it an expander head. And I always thought it related to the polyethylene, but it's not. It relates to the pipe that the polyethylene is being pulled through because we're expanding that and we're fracturing that host pipe. So are we actually putting the bolts directly into the polyethylene?
In this situation, absolutely. Yep.
Yeah.
And it holds just fine. No issues. All of these heads slip right over top of it and everything holds into the polyethylene just fine. What you're seeing here in the bottom left picture is also a lubrication port. If we have too much friction forces within a pull from dense soils or otherwise, or maybe a longer length, you can also put lubrication through that to make it easier. And what you'll see on the right then becomes white polyethylene or gray polyethylene. It makes it easier for that closed circuit TV camera to go and actually capture images within that pipeline itself. Now, not having that carbon black within the pipe, we have limited time or lifespan above ground. We typically want to get it installed within a 2-year time period for manufacture. So here's a video, just an open excavated pit. Please observe how close we are to that third-party utility that's there. If we do know of a conflict or a potential conflict with a third-party utility, we excavate to make sure there's no soil that pushes off into that third-party utility. And here we're simply bursting through a vitrified clay pipe. So we did get some questions about ductile iron or cast iron. Cast iron can easily be burst. Ductile iron happens to be on the developmental phase, and we'll talk more about why that is in a couple of slides here too. So here's yet another. Sorry if you're having your lunch there. This is gravity sewer pipe bursting, pulling along with that constant tension winch as we move through this. And this is bursting asbestos cement pipe. We did open up that pit to be able to provide access for the machine to pull that along. And there's that expander head bursting that AC pipe. Now, as you see, everything stays wet, stays in that hole. Any asbestos fibers now have been fully wet by that hole through there, and then remain in the excavation itself. So another innovation within pneumatic pipe bursting happens to be a reversible pneumatic system. So we can take that expander head and remove it from the front of the impact hammer. Once it arrives at the manhole, as you're seeing here, we remove that expander head through the manhole, and then you can back that tool back out of that production pipeline that you put through proof. So we're actually saving one excavation in this instant. And many times you can turn the tooling around and pipe burst from the other side. So then you're still saving that one excavation by not removing that manhole through it. If it is intended for the manholes to be removed as part of your project, sometimes we pipe burst first and then remove that manhole to replace that manhole, as the compaction around that manhole is going to be strong before that manhole is replaced, and we'll burst right into that manhole. We'll talk about manhole preparation here in a little bit as well, for what's necessary for it. So this is a static pipe bursting, and essentially we're applying the force just in different manners. We have a static bursting unit in a machine pit in one excavation. Then we're pushing those rods or cable out into the existing pipeline as we go through, connecting to roller blades, cutting tools, anything that we have, and then pulling that expander back. That pipe stays within the 2 to 3 inches of soil surrounding it in the temporary cavity that is left by the larger size of the expander head as we go through. So here's some examples of what's called an extraction cage. So you'll see here the expander head in the left picture is arriving in the extraction cage, and then the bursting operation is stopped in order to be able to allow crews access to that expander head to remove it. The extraction cage doesn't necessarily have to be aligned for the entire pipe bursting mechanism. Sometimes they pull that machine back, install the extraction cage when they're nearing the end, and then remove the equipment. And the alignment, proper alignment of the machine, as what you'll see here through it's resting on I-beams that have been pushed into the ground, then that stops and resists that force from moving forward through there. So yes, Peter.
Just got a great question, Alan, and I did not know the answer to this. That's why I love these webinars. So Jason LeMay out of Nebraska, Lincoln, Nebraska to be specific, is asking, on a static burst, when you attach the drill head or the pull head to the front of the polyethylene pipe string, and you're running the bolts into the polyethylene, how do you maintain a clean interior pipe when that happens?
Okay, that's a great question. So contractors use many different tools. Sometimes they fuse right onto a swivel that has no opening in that manner. Other times that drill will just enter not all the way through the pipe wall thickness as it goes through, but also for most potable projects, as we come back through and take that head off, they are going to flush that pipe, and they'll flush it with superchlorinated water and use a foam pig to push anything that may otherwise have come through during that pull-in process. So there is additional flushing through that. Rusty, did you have something else to add?
I did, yeah. If you look back at that particular slide, we don't have to go back to it, but it looked to me like that was a solid head. It looked like there was a bolt in the back there. See, about 6 inches back from that head. I believe that may have an internal metal component as well that could be capped off. And then that polyethylene is just cut off. Obviously, you're not going to use any of that in your system, and that might keep that clean as well. So I'm not positive about that, but it looks to me like that is a nut that is countersunk into the pipe right there. So I think that head may be internal and external, which would make sense. It would make it very, very sturdy. The other thing I was going to comment earlier, been to a lot of these different pipe bursting contractors, and man, they just have a variety of heads. I could not figure out what, where, how, but they can kind of develop what you need for your different project. And they're all a little bit different. Just like you said, some have cutters, you know, for a different material, you're going to need a cutter on it. Others are just hammering it through. So your contractor, pipe bursting contractor can definitely help with some of that stuff, as well as making sure that you're not getting contamination in. So.
Absolutely. So one of the beauties about working with HDPE is how rugged and durable it is while we're working with it. So anything that the contractor may have used to screw into while we are actually doing the operations then would be cut off, and then we'd fuse to final connections or use other connections in the like there. So these are some close-ups of the hardened quick lock rods, and then also the hydraulic power pack, and that provides the force that's necessary in a static bursting operation. So the tonnage that is applied during a pneumatic operation is significantly lower, as that impact hammer simply inches along with the existing pipeline. In static, we're providing force across the full length of whatever quick lock rods or rods we have out, and then we are providing that force to break that pipe on the downstream end of this. Could be 300-500 feet. It could be however many long that is away. So we're looking in the sub 25 tons for pneumatic, and then we're looking in for big pipe and static. We're up into the 250 ton type of machinery when we get into very large pipe as we go through. So static pipe bursting. This is why sometimes when I talk about pipe bursting, I use the term surgical excavation as we go through neighborhoods, as some of these entrance and exit pits for even the machinery as we get aligned through this can be very, very small. And that excavation then, of course, directly relates to reduced restoration in a suburban or urban environment. That could be a fairly significant amount of cost savings for projects as we move through. So some of the applications we're looking at are gravity sewers, potable water, storm sewer, process pipe, raw water conduit, any type of new pipe that you have that we can pull, or pipe that needs to be replaced as we're pulling through and putting that new pipe back into place as we go. So existing pipes that can be burst, or AC pipe, yes, it is legal. There are regulations that need to be understood and controlled while you're working with the asbestos cement pipe itself. It's not within the Clean Water Act or the Drinking Water Act. It's within the Safe Air Act. Clean Air Act, as to which the National Emissions Standards for Hazardous Air Pollutants governs working with asbestos cement pipe itself. So any other interest in that, you'll have to email me directly. That's a multiple hour conversation and discussion as to exactly the regulations that surround working with AC pipe. But AC pipe has been burst in Florida, Texas, state of Vermont. It adopted a formal process as an alternate, and then also now in the state of California, in the Bay Area Air Quality Management District, they're bursting AC pipe as well. So cast iron pipe is fracturable and easy to burst. VCP, vitrified clay pipe, those are very common to burst. Non-fracturable pipe will often have to cut. When we get into pipes like ductile iron, the failure mechanism of ductile iron will have that pipe want to close back in on itself in the shape. So it is in the developmental phase itself. So here's a video of an AC pipe being fractured. Normally we wouldn't remove that much soil, but in this area we needed to show what was happening with the actual AC pipe as it goes through. And you can see this pipe is easy to break and goes into the 2 to 3 inches of soil surrounding that replacement pipe as we go through. And here's some cast iron pipe that simply is getting fractured and broken. Cast is a very good candidate for breaking in this manner, as it's very easy to break, and those fragments of cast iron simply just push out into the 2 to 3 inches of soil surrounding it. This technology was developed by British Gas. They were replacing quite a bit of cast iron pipe within the streets of London and everywhere else. So they wanted to get as many techniques as they could to reduce that excavation. In the UK, they dragged a 3-meter section of sacrificial pipe in advance of the actual production pipe to look if any of those cast iron fragments were gouging that high density polyethylene and determined that none were gouging the high density polyethylene, and it's not a problem to be able to pull that through a metallic pipe in this manner. So keep going. Existing pipe materials that cannot be burst going to be a multiple piece pipe material such as a pre-stressed concrete cylinder pipe or a heavily reinforced pipe that has multiple pieces that work together to be able to provide the strength of that pipe as we go through. Ball and socket ductile iron pipe is also a reinforced joint in that manner that cannot be burst through. Types of pipe that are challenging for bursting: a ductile iron pipe, as I stated previously, and then corrugated metal pipe. As much as the industry would love to be a solution for a lot of that pipe in stormwater applications, that lack of hoop strength within the CMP actually then accordions up on the expander head and then has stored energy that has to be cut off once the crew's daylight through the other side. So there are challenges associated with it. It doesn't mean that you cannot burst these. It just means that you certainly need to talk to your contractor to be aware of the potential for conflict and what is necessary to be able to cut these as well. So some of the range of diameters and lengths on the industry, the largest pipe burst that I've heard of is about 48 inches, but there's equipment that's already manufactured and ready for 54-inch pipe. The longest lengths that we're seeing really aren't limited by the technology. They're limited by the design of the systems. So as you can see, long lengths in transmission lines of greater than 1,500 linear feet as we go through the pipe, but most of our gravity sewer systems and potable water distribution systems are set up with valves or manhole spacings every 300 to 500 or 600 feet. And since we can't burst through the valve, that now becomes an excavation point for us. And we're focused on productivity within that 300 to 500 feet range as we go through. So we want when we design pipe bursting projects or look at the layout of them, we want the crew to be as productive as possible. So we're going to look at the number of connections, the number of pits that need to be looked at or opened up to perform those connections, and then that will limit a productive day for us. It is atypical to burst through valves, but we do have video of bursting through valves. And I will say that the pipe bursting equipment does not care what it's bursting through. And if it does get stuck, then it becomes an unplanned pit. There's not a superintendent on the job site that is not ready to dig an unplanned pit. What do you think about that, Pete?
Yeah, well, I don't know if you plan on showing that video today, Alan, but that's one of our most popular videos. But quick taking a step back, Alan, what's the elevator story on why I would pick static bursting versus pneumatic bursting? We've got a couple questions on that.
So static itself allows you to seal the inside of the pipeline for disinfection purposes. We'll talk a little bit about pre-chlorinated pipe bursting here in a minute, and I'll walk through the whole process through that. Because we do not have an air compressor hose or an air hose through the inside of the pipe, we can maintain disinfection through there. Now, if for some reason you wanted to pull some other type of pipe than high density polyethylene, you'd have to use a static rig as well. You can only use high density polyethylene with pneumatic pipe bursting rigs. But generally, gravity sewer uses pneumatic, and then static is for potable water applications. I'm glad that you asked to clarify that. So some of the real savings in this family of trenchless technologies versus traditional open cut construction in a pipeline market, EPA has studied this, their technical research arm, to see what kind of savings we're going to see for reduced carbon emissions. It's fairly substantial carbon emissions. As you can imagine, we are not hauling out any unsuitable backfill through this and not hauling in in new backfill for the entire length or the run of the pipeline that we're putting through. Generally, the equipment is smaller. We don't have to open up as much excavation throughout the entire project length. So our equipment does get smaller and produce less greenhouse gas emissions in that manner. We're doing quite a bit to save a whole lot of environment. So we can go through neighborhoods with established urban canopies, as you'll see here in the Sausalito Shores neighborhood picture in the top right. This neighborhood in particular had a rear lot line for gravity sewers, for electric, for a lot of other utilities. And then the front was potable water, gas, and buried telephone. So these 60-plus-year-old trees we were able to save by using pipe bursting versus traditional open cut. And Rusty, yes, please contribute.
Yeah, I was just going to jump in, and you're talking about the trucks for the backfill and having to bring in new fill and everything, but you also got the asphalt replacement if you're having to tear up roads and cross those. You've got the concrete if you've damaged sidewalks, driveways, and like you said, a lot of these neighborhoods that need this new piping or larger piping are older homes, maybe built in the 40s, 50s, 60s. You have that old growth like is shown, and it's just critical to be able to save that type of environment. So I think really the environmental impact is probably underestimated. I think there's even more we're doing to help save the environment by utilizing these trenchless technology, the variety of the trenchless technology methods of installation. So that is something we're looking as a company, looking further into through our ESG and everything. So yeah, I think it's very key.
Absolutely, Rusty. City of Houston is one of the largest consumers of polyethylene, and they use 80,000 linear feet a month. There's a whole lot of redevelopment that now requires a larger pipe, and they're solving for a lot of inflow and infiltration issues as well that was not corrected by cured in place pipeliner. So that brings us to the next slide, which is pipe bursting versus some of those other rehabilitation methods. And one of the biggest things that a contractor friend of mine had pointed out was you are not getting a field made pipe. We are putting in a pipeline through pipe bursting that is made in a manufacturing facility that goes through rigorous ASTM standards and testing controls in order to be able to prove the lifespan of that pipeline. So we are not creating this pipe in the field when lots of other things can happen during the installation of the pipe that have to have very attentive quality assurance and quality control as we go through. So what you're seeing here is field made pipes that have now lips or other problems within that cured in place pipeliner. And the only way to be able to rectify this is to excavate and cut that section out. So your crew has to be fairly attentive to successfully install a pressurized cured in place pipeliner here comparatively to gravity sewer, which has a lot longer history in CIPP. So one of the things that is not addressed sometimes through CIPP, and most of it happens to be the reinstatement of service connections, happens to be any inflow and infiltration that may not be corrected, which is one of the primary reasons to rehabilitate these pipelines initially as well, is to make sure that we're not building larger treatment plants than we have to because we've got a whole lot of groundwater pouring in through cracks in other places. So we want to look at planning feasibility analysis. Now, I had mentioned previously that there's not a superintendent on site that is not ready or expecting to have to dig an unplanned pit. And the same thing with concrete encasement. It doesn't necessarily mean that your project is over because there's concrete encasement around your pipeline. It just means that we have to either be creative in the way that we fix it. As you'll see here, the utility conflict structure on a City of Tampa job was easily avoided through taking advantage of the allowable bending radius of HDPE and put right behind that conflict structure instead of through it. or what you'll see in the bottom right now just becomes full-blown concrete encasement that becomes an excavation. So that was a bad day, but that wasn't necessarily a bad project. Some of the things that we're going to look at to deter pipe bursting, or if we cannot access the pipe in any way, shape, or form, i.e. it's underneath a railroad, underneath a water body, underneath someplace we simply cannot dig down and access to it, then that may very well preclude our pipe bursting project from happening. Here's a classification chart that was developed by the International Pipe Bursting Association years ago. And essentially, it takes us from A projects, which are the bread and butter. Those are size on size, burst lengths of 350 feet or less. Those happen every day by multiple contractors all over the U.S. And then get up to D, then the developmental phase, and that's that cured and plate, or the CMP and ductile iron pipe bursting. Excuse me. So we're looking at B, which is the single upsize, or C, double or triple upsize. Here's another way to be able to look at this. And one of the things that I would like for us to realize as we increase the OD of that pipe, the majority of that increase now comes through what's called the spring line of the pipe. It's the theoretical center. Now that theoretical center with a larger OD now raises as well. So if we have sensitive laterals at low slopes and in gravity sewer, when we're raising that, the industry has created a low rider saddle, which can go below that theoretical spring line for the pipe. So Cornelius O'Connor asked a question about sags in sanitary sewer pipe. Sags in a sanitary sewer pipe are basically going to be a void of material underneath that pipeline that provides us with an area as to which we may very well get accumulation of grease or other debris. Pipe bursting will not correct a sag. It can smooth them out. So some contractors and owners that have TV'd beforehand and recognize that they have sags, then also include a point repair within the contract, to where if that sag after that pipe bursting operation was not corrected, then they can go through and correct that at that time. So typically pipe bursting will not correct a sag, but it may very well smooth that out just from the curvature of the pipe itself. So we had another question from Eric Lopez as well. Has there been any lessons learned on using static bursting for projects where the existing main is under buildings or under pavement concrete areas at shallow depth? With the deflection or the displacement of soils, which we'll talk about here more in a minute as well, if we can control pressure aspect on top of that pipe, i.e. they can park a dump truck on it or something else with steel plates, sometimes we can force any soil displacement out instead of up. And then it also depends on soil conditions and strength of that soil condition as well. Here is another look at a Class C pipe burst. So that could be 10-inch to 16-inch, which is a triple upsize. And as we get deeper, the force required to displace that soil column on top gets larger, but we may very well be able to absorb all of that potential for heave within the soil column. So the general rule of thumb becomes 1 inch of expander head above that ID or OD of the existing pipe. We need about 1 foot of space above that. Now that's just a rule of thumb. There's a restoration item within most pipe bursting projects that you bid, and simply if they do heave in certain areas, they are required to restore it if you write your contract that way. So this design elements that we're seeing next are similar to just about every pipe rehabilitation project that you would do. There are certain aspects that because we're using the proven conduit location of an existing pipeline, we can have some fairly significant design savings. So it's a contractual approach difference by using that existing pipeline. We know we have a proven space that we're already using for an existing utility that's free and clear of some conflicts with third parties' utilities. If we're installing a brand new line, we oftentimes as diligent engineers have to go through and say from point A to point B, yes, that path is clear of third-party utility conflicts, and we need to do lots of design work in order to be able to prove so. So here, this is a city street in New York City that Pete dug up, not literally, but dug up the photograph of. And when I say that that proven conduit location now becomes a commodity for me, you're starting to see kind of sort of why. So any amount of work in a very dense utility corridor like the one you're looking at can be pretty challenging in developed suburban and urban areas, even in Orlando, Florida, in a lot of places in California, certainly Texas and Houston and Dallas. It does become rather challenging to find that new space. It becomes challenging to find not only the horizontal space, but the vertical profile that's free of third-party utility conflicts as we go through. Once we understand that that proven conduit location is our commodity, we can then shape our plans and our projects to be able to take advantage of that. So we will look at as-built documentation, GIS records, location of repairs. The reason why repairs are often important to us is that repair change, either a change in material type or a heavy duty repair fitting, oftentimes cannot be burst through. And so we want to know where those are and what is required to get through that as well. So yes, Rusty, thanks for coming on.
Yeah, I was going to mention, that's a very good point on those repair bands. You generally have a different material, and it's not that they can't be burst as you're showing there in the photo, but you definitely need to be aware of where those are. So again, the as-built, just like any project though, it's not very different from having to do an open dug, trench. You got to know where those other utilities are. You got to know where your valves are. You got to know where these things are. So even though you do have to have very good, accurate as-built or the information on that, it's no different than any other project. So
great, certainly good to contribute there, Rusty. Thank you. We've gotten lots of good questions coming in. We're one from Robert Allen talking about very large holes in the pipe, whether or not that would become a point repair prior to bursting. The bursting mechanism doesn't care about holes in the pipe itself. They'd simply burst through that. And then also, as long as you could fit the cable or the rods through the pipe, even if it's got root intrusion and other things of that nature, we will not need to come through and clean all of that out. And then we had another question about bursting 2-inch HDPE or PVC. One of the problems and challenges with smaller diameter pipe may very well be the same in fitting that cable through that pipeline itself. Lateral bursting rig that the Alliance for PE Pipe uses on the show floor has a smaller cable that is intended to be in pipes sizes 6 inches and smaller, and you may very well be able to insert that into high density polyethylene and then go from and cut through that at that juncture. So thank you very much, everybody, for the Great questions as we go through, and we'll keep going. Geotechnical investigations, what we're looking at is two things. We're looking at the ground conditions, whether or not we put backfill material within that excavation when we first installed the pipe. And then we're also looking at the trench condition. So if we have, say, the worst case scenario where we're digging out a rock trench and we have just barely beyond the OD of that existing pipeline, for the actual trench itself, we're not going to be able to put that expander head or displace much soil in a rock trench condition. If we do have very stiff clays that make it hard for that expander head to be able to push up to create that temporary soil cavity, we may very well have additional forces necessary to be able to push that heavily stiff clay up and out a way to be able to make room for that new pipe. So what we're looking at and preferred is that originally compacted backfill. That backfill, when it is pushed up, it creates that temporary soil cavity, and it uses actually creates a stronger soil at that soil arching interface. So when that expander head comes through, the bottom of that soil that just got pushed through this actually arches like corn in a silo would do, and then that gets stronger in that manner. So that concept over the years has often been hard for Department of Transportations to understand when we're moving through and they're worried about the compaction of the backfill on top of it. But in the 1960s, Tersaghi is a very well-known geotechnical engineer, and that soil arching theory came directly from his noggin and his brain through that as we go through. So in here, that brings us to soil displacement. So I took the liberty of adding just some expander head diameters above what we see from traditional VCP pipe, and you can see how much is actually displaced as we get up and bigger and bigger and bigger. Yes, Rusty.
Yeah, I think you're touching on a lot of the material that was coming in the questions. There's a lot about displacing other utilities and shallow pipe going under concrete driveways, that type of thing. And really, it is very much tied to the material that you're going through. Like you said, a dense clay, may not get a lot of movement, or you may have enough that you can push that to the side. It depends on the piping as well. And I know we had a question on doing same size or upsizing, and that's the same thing. A lot of those are going to be based on your project, the pipe material, the soil, and how close those utilities are. So a lot of that will have to be, some of those questions would have to be done by probably your pipe bursting contractor to kind of answer some of that. But I mean, we've seen jobs go on, upsize 2 and 3 times, the pipe size. So it's very possible, just depending on your materials there.
Oh, yeah. For third-party utilities, when we know about it by doing potholing before that process comes through, we remove any soil that could push into that third-party utility, so that way there's not a direct conflict. Francisco Martinez had asked through the chat function, now just a reminder, with well over 30 questions as we keep going, and I know you're probably going to have even more, so make sure that they're in the Q&A section instead of the chat function. But vibration, and this slide title here really shows us and discuss about vibration. It is unique to pneumatic pipe bursting. Static pipe bursting simply does not have the vibration associated with that impact hammer. So if we are next to a sensitive structure, you certainly first consider static pipe bursting instead of pneumatic pipe bursting. And then a brilliant researcher named Dr. Alan Atala had conducted a very substantial study on peak particle velocity and its transmission through soils. And here developed this general rule of thumb that we didn't want to be closer than 8 feet to residential structures. Commercial structures are in the 3 feet range, and buried structures such as concrete vaults or vats and whatever else we might find about 2.5 feet away. And so this really is measuring the impact wave that's sent out through peak particle velocity threshold within the soil column as we go through. So great question, Francisco. You guys are thinking about everything. I mean, I don't even have to be here. It's perfect. Talk amongst yourselves. It's wonderful. Project layout here. Obviously, as we get bigger and bigger and bigger with the equipment, with the pipe, then the site layout needs to be larger. So you'll see here in this in comparison, very small pipe bursting rigs, since we have very shallow depth, very small pipes, and then a larger rig where they just decided to shut down the entire road to provide access on a pneumatic pipe bursting system. So we did get asked about allowable bending radius. Typically what happens as the limiter in both pipe bursting and horizontal directional drill is not the allowable bending radius of the high density polyethylene, but the bending radius of the drill string or the quick lock rods or the rods that are used for that. So those are typical limiters themselves. So here's some pictures itself on what we're aligning this pipe through. So pulling that pipe from the laydown yard to where you're lining up at that pipe insertion pit. Sometimes we push that pipe through its limits, as you could see here, and controlling how that pipe is directionalized. So it's oftentimes uses tires and other things, and I've got more in a few minutes. So the pre-chlorinated potable water main pipe bursting processes essentially fuses up long strings of pipe in advance. So we can do multiple things. We can flush them, we can pressure test them, and we can also disinfect them. So all three of those things are conducive for one employee, as you're seeing here, go through and seal up the pipes. They fuse them all the long runs together. We identify long, narrow laydown yards so as close as we can get to the pipe bursting process. But while we're pulling that into place, it actually does not impact traffic very long. But once we have flushed, pressure tested, and proven that the interior of that pipe is disinfected, that disinfection can stay within 60 days. So that we have an outage of the block or run that we're pipe bursting. You pull that pipe into place, turn everything on, and then since we know that pipe interior is properly disinfected, we can have a limited outage period of your customers of 4 to 6 hours. It's a very robust process. So here you see a poly horse and one employee simply fusing long runs in advance. Now the other guys on the crew can go out and do exploratory work or the actual pipe bursting run as they go through it. And hopefully this gentleman doesn't get too bored through that process of fusing pipe all day, but hey, that's what they do. The tools are set up and designed with these types of things in mind. So construction considerations, now we look for submittals and shop drawings like on every project as we go through. The superintendent on the job will have to do their inspection as well, to their site investigation as they go through it. And then we're looking at construction sequence, observations, field testing that's required, and everything else we could do at the end. So proof of that qualification, we want to see that Fusion card. We want to see Fusion certifications, of course, material sheets and everything else. Rusty,
Yeah.
I'm sure you've submitted a lot of these in your time too.
Oh yeah, definitely have. And it is key for sure. We did want to, we've got a question that we wanted you to answer live, Alan. It's from Jerry Parsh.
Okay, great.
You
So
see that?
Jerry, yeah, I do. Right. I'm looking at it right here. So if we want to upsize from 8-inch to 10-inch ID, should we figure the pipe flow line will lower by 1 inch? So absolutely. That's a great question to ask, Jerry. Most of the displacement of soil while we're performing gravity sewer pipe bursting is up and out. It's not down. So when we're trying to keep that flow invert exactly aligned for gravity flow, into the manhole and making sure that all downstream or upstream as we come to this are not impacted by lowering that flow line. In gravity sewer, it's up and out. So yes, you can assume that that invert elevation still stays the same. So very good for that. Thank you very much for that clarification and the opportunity to clarify in that manner. So so here, one of the things that we're paying attention to also is bypass plans. As that pipe gets bigger, so does the challenge of a temporary bypass as we look forward. So a lot of these site layout plans or what have you, when you have a pipe bursting or an owner very familiar with pipe bursting, sometimes some of the more complex aspects are not necessary within the actual plan as it goes through. When we get into very complicated projects that require a lot of attention, then you would develop more of that site plan as we go through here. So I often minimize design altogether on pipe bursting projects and then require the contractor to submit a bursting plan, which shows where their insertion pits are going to be or machine pits as part of a shop drawing submittal. And then therefore it shows that that contractor has in fact thought about the steps required to be able to perform that pipe bursting project. So that contractor superintendent, he's going to have to do the site visits that your design engineer and your owner just did as well. So they're going to ask all these questions all over again with the existing pipe material. They specifically want to get to what will stop the advance of the pipe bursting equipment that will require me to now dig an unplanned pit. And where should I lay out my pits? And where should I get my temporary water and things like that as we go through? So Diane asked us a great question about pipe bursting through multiple manholes and then reinstating channels as done in CIPP. Absolutely. So the next slide for us here is going to talk about that construction sequence as we go through. When we're pipe bursting through multiple manholes, obviously the length of both runs then is additive. With the cable that we have, we simply break out the manhole wall to allow access for that pipe to move through. And as long as there's no change in that alignment, you absolutely can burst through multiple manholes through that efficiency and looking in that manner as well. Then you can rebuild the manhole in whatever way, shape, or form you're looking at for the channel as you need to have it rebuilt through there. So here's a quick video animated GIF on productivity tools. We try as hard as we can through the Alliance to limit this talking head as much as possible. I try to be entertaining through this, but these videos show you 1,000 words. The machinery is set up to be able, 1,000,000 words, picture shows 1,000. The machinery is set up to be able to make it easy as possible and then also face that pipe. So what's not being shown here is the next step is to cut the ends, both ends of the pipe to a completely flush face. So that way, when we do put them on the heater plate and we start to fuse it, that joint is absolutely as strong, if not stronger than the pipe itself. And this is set up in order to be able to maximize the productivity of that one crew member. So here's just larger pipe, and the equipment is designed to do exactly the same stuff with handling all of the hard work for you. As you could see in the left video, that pipe machine butt fusion machine simply advances along the pipe to the next joint and it clamps down and holds that for you. And then they can also be fully automated, as you see here in this other video, as this being controlled off-site while not even touching the machinery as we go through that. We do have to look at maintenance of traffic. So in some instances and areas, the actual activity of moving the maintenance of traffic into travelways can eat up quite a bit of your production time. As you see here in this Courtney Campbell Causeway project in the bottom right, it took 2 hours of a 10-hour closure to move equipment onto and off of a pipe bursting road as we went through this project. But a big saving for this project is they replaced 1,800 linear feet of 8-inch cast in 3 weeks. when traditional open cut would have required temporary barrier walls, traffic shifts, and taken at least 6 months with lots of impact. So here's more of that manhole preparation, Diane. Thank you very much for giving us the opportunity to answer that wonderful question. You're thinking about it a lot. We simply break out that wall to allow access for the pipe bursting equipment. We align in the center picture that that harness in with the manhole wall to make sure that the cable that we're using is properly aligned with the spring line of the pipe. And then here we are looking at that expander head that subsequently can be removed from this pipe bursting application and then removed directly through that manhole as we go. Maintaining service is important for gravity sewer. They oftentimes use door hangers that come through and say, hey, please do not use your sewer from these hours while we're doing this work. Sometimes people don't listen. Can you imagine that? And so they do have temporary plugs that they can put on there in order to be able to stop any type of sewer coming from the lateral as that main line is being pipe burst and then the laterals are being reconnected. You do have to protect the temporary bypass as we go through. And sometimes the contractors can get pretty creative as to where they put this temporary bypass. We do entire presentations on temporary bypass themselves. So look for future Alliance webinars as we go through. So one of the key things that we're looking for with pipe bursting equipment is proper alignment to distribute that force correctly. So I had mentioned previously I-beams put into the ground that basically stops a static rig from moving through the soil and pulling itself through the soil column. And then the constant tension winch aligns to make sure that that impact hammer is aligned with the existing pipe as we go through. So those are routine things that can be inspected and looked at as we go through. Moving that pipe from the laydown yard. I try to look for possible laydown yards for at the max a mile away from the site. Sometimes we're don't have that luxury, but the actual timeline to be able to move a drill string, or I'm sorry, not drill string, a pipe string from the laydown yard to where you want it to go in the pipe insertion pit sometimes doesn't take that long. You can monitor the rate of advance of the equipment by counting the joints on the HDPE pipe direct with measurement. It is very common to get into the 3 to 5 feet per second range as we move through. No, not feet per second. As it goes through, it can get pretty aggressive in how quickly along that pipe bursting operation can move through. I'm going to have that stat for you right here. It's right here in the back of this brain right there. I'm going to pull it forward while I'm still talking. So here's some examples of how we move that pipeline to that bursting operation. So here's a laydown yard as to which they've directionalized this pipe up against this dumpster and used this 4x8 piece plywood to be able to protect it. The next night, the guys forgot the 4x8 plywood piece and now subsequently gouged this pipe. And I'll show you exactly that gouge here in a few minutes of what is an example of an okay scrape and what is an example of a bad gouge. Rusty, yes.
That's exactly what I was about to talk about. Just the fact that, one of the great characteristics of polyethylene is that abrasion resistance. If you notice, a lot of the snow plows in the northern states use polyethylene on the base of those to keep from tearing up the roads, but it's still a very, very durable product. But as you said, you can damage it. A tooth of a backhoe, something like that can definitely do some damage. And the general rule of thumb is you can lose about 10% of that wall thickness and not have a problem with your operating pressure. It would still be good for the manufactured operating pressure, but it's very, very, very durable. That's one of the mines have used it for years. But yeah, you do have to do some inspection and make sure you don't get too much of a loss there. So the other thing I was going to mention with all this, we talked quite a bit about that zero leak rate of polyethylene. So again, with these trenchless technology installations, you're still getting that zero leak rate for polyethylene pipe. So I think it's just critical when we're looking at the droughts and everything that we're dealing with right now. So I know we're getting shorter on time, so I will turn it back over to you.
Great. And Rusty, that gave me just long enough to be able to think of the stat I was thinking of, and it's 3 to 5 feet per minute, thus giving us a 500-foot pull in about an hour time frame. So yes, it can pay out all of the rods and cable in that hour, 45 minutes to an hour beforehand, and then the actual act of bringing this pipe bursting head back through, expander head back through, can take that hour as well. Most of the work is done up front in prepping the long strings. As we've shown, the industry has tools to make it as easy as possible, and then digging the pits and making those repairs. So I didn't forget that stat. I just had my minutes and seconds wrong on that standpoint. So I definitely appreciate the opportunity to think back and clarify. So here you're seeing some drill or string that's attached for the pipe bursting mechanism, and a unique way for the machinery to be able to make sure that they're winding up that string. And again, just burst in cast iron. This is a video from No Dig Tech in Texas. John Newell does quite a bit of pipe bursting as we go through. So the expander head, of course, doesn't care what it's pulling through. So if it didn't break the pipe in that situation like this, it'll pull it through the ground, and then the crew simply just breaks it off of the pipe as they come. So in the construction sequence, beyond that pipe installation, we look at reconnections, manhole replacement for sewers, and all sorts of other restoration items that we're looking at. There are lots of different ways to do those the reconnections. So the industry has quite a lot of tools to do either mechanical connections, or we'd prefer for you to be high density polyethylene for the entire run. That way you get the full monolithic benefits of leak-free system that Rusty had mentioned. And then they have sidewall adapters, they have fittings for electrofusion, and then you can also always butt fuse in the excavation as well. So all of this equipment, as we've got, as you can imagine, is designed to be taken off of the equipment there, or off of the chassis, and come down into the excavation to be able to perform all of that. So yes, we've got a little bit of discussion on time. We've got about 9-10 minutes left here, getting right into the end of the material. And thank you all so very much for staying attentive and looking at all of this while we go through. So one of the big things about connecting high density polyethylene is to make sure that when we connect to a bell and spigot system, that we are not going to pull that bell and spigot out. So we are not connecting for the benefit of the polyethylene once we have fully fused joints, either through electrofusion or sidewall fusion, socket fusion, butt fusion, any types of the fusion. That pipe material is self-restrained and will not pull apart. We now need to have a restrained connection to not pull the bell and spigot system out. So what you're seeing is a little animated GIF here of an MJ adapter, which will be the belt and suspenders type of adapter for us in restraining connections to valves or other pipe materials. So here we've had a great question about municipalities, whether or not they need to have special spare parts when they start to use HDPE pipe. A long-standing response from the industry was, once you install HDPE, it does not fail, so you don't need to make repairs. And a lot of municipalities out there go, oh yeah, we don't buy that for 1 second. But most of the damage to high density polyethylene happens to come from third-party damage, which none of us control. And there are lots of repair clamps and repair things available, fittings available for you. So the Municipal Advisory Board of the Plastic Pipe Institute also has created repair manuals. That way, if you're, it's a plasticized manual that if it's in the middle of the night and your crews are out there working at 2 a.m. on a repair, because the water main break doesn't happen on a Tuesday at 9 a.m. It happens on Christmas Eve at 3 o'clock in the morning. I know from example, I've had to tell 25,000 people on Christmas morning they couldn't drink their water. It was much more challenging than you think. But here, there's lots of different ways, and your standard fittings can often be used as a temporary repair on high density polyethylene. We would prefer you come back and do a more permanent repair, and there are lots of fittings available for that as well. So great questions. Here's just some examples of additional fusion examples for you itself. So construction observations, we want to monitor the rate of advance of the machinery. That shows whether or not we're going through challenging soil conditions, or maybe hit a unidentified repair clamp or something else of that nature. And then here we get to scrapes and gouges. So there's a 10% allowable gouge or gouge allowance with an HDPE. So it's the percentage of the full wall thickness of that pipe. And the way that we would measure it in the field is Home Depot has dowel rods that they sell in certain sizes that are specific that can be tracked for that gouge. There's also potentiometers that can, as you move it across the surface of that pipe, it'll have a tool that'll stick out and stick into the gouge. But what I say typically is, when in doubt, cut it out, even at 3 o'clock in the morning. If we've noticed that gouge, which Chin, the superintendent that you're seeing here in the bottom, that's what I made him do at 3 a.m. And then all they do is use dry chainsaws to work with this material. That gouge was cut out and refused within 30 minutes. And then that process just continued to go through, and the crew did not lose much downtime and productivity as well. So these are examples of just some scraping of the pipe along the street or the surface of the road. They didn't use sweepers or other things to properly prep the surface. You can also use rollers if you want. And this is the bag gouge that Chin cut out at 3 o'clock in the morning after pulling against that dumpster with an actual protrusion. So the very first thing I do as a construction inspector is, once that pipe arrives at the pipe insertion pit, I walk the entire pipeline, and I also track its movement from the laydown yard all the way to that actual pipe insertion pit. Some of us do it differently. Dan Landy likes to make some fun out of it, and we have videos of him running down the street as fast as he can after a pipe string in California that they pulled into place. And maybe next time we'll show you that video. It's rather comical through that. Trying to keep up with this construction crew as we go through. Bedding and compaction, we do an open cut construction webinar. We'll do one next year, so we'll talk more about proper compaction of material and how that pipe stiffness and soil stiffness work together to displace the loads put on top of the pipe. A data logger can be incorporated to make sure that every joint that you put together is a solid joint, and your operators that have fusion qualifications are going to love to be able to do this. It's integrated into the process in the machine right there, and data loggers are very easy to be able to track that process as we go through. So here we come to an unexpected stoppage or an unplanned pit. Again, I'll go right back to the very beginning of this webinar. There's no superintendent on a pipe bursting job site that is not prepared to do an unplanned pit. Things happen during construction, and here's two primary examples of it. What you'll see on the left there was a swivel or a pull head that had been fused and refused and reused and reused and fused and refused, and finally eventually sheared off. The crew itself had not noticed until the expander head was 25 feet away from where the production pipeline stopped moving. So quite a bit of feverish calculations and measurements had to be made, because now they were digging two pits as the equipment separated. We essentially have a pipe bursting machine operator, and then somebody on the opposite side to watch as that pipe advances. So this would not happen. And in that situation, it was rather early in the morning, and the operator wasn't paying as much attention as they potentially could have. But that just became two pits that were dug the next night. They found the equipment, reconnected the pipe bursting process, and started to pull again. So what you'll see here on the bottom right, of course, is a large boulder rock that simply cannot be pipe burst through or around, or you're not going to move that boulder through with the pipe bursting equipment. So it did become an unexpected pit as we go through. So, of course, you take pressure tests prior to installation of the pipeline, bacteriological samples for water in that standpoint, post CCTV for gravity sewer. That's why we talked about gray pipe as opposed to black pipe. For gravity sewers, is it'll reflect that water through, and then compaction testing for our backfill as we've come as well. As-built documentation can be as simple as what you prepared your design plans for. I used for 42 plus miles of pipe bursting work, GIS records, and that's because we're taking advantage of that proven conduit location as we went through. So by acknowledging some risk in putting in a pipe bursting plan submittal as part of the submissions process, now we are sharing some of that risk with the contractor. So great question so far. We have over 55 questions. We have a little bit to talk about on resources, but only 1 minute left, so we won't bore you too much with it. Rusty, if you want to come on and have any closing arguments, now would be a perfect time. Kevin, you raised your hand and told us we've got some other discussion here. So thank you all for the questions. Again, here's all of our contact information if you have additional questions. And Rusty, what you got for me?
Hey, I'm just going to say, if anybody would like that NUCA manual on trenchless technologies, it compares the different things, shoot me an email. I'll be happy to mail that out to you. It's a very good resource. And again, just I think it's been a great webinar. Hopefully everybody's questions got answered. You know, we can continue to answer those. If you have things that come up, shoot us an email. We'll be happy to help with anything like that. And the engineering package, again, we've talked about that. PPI also has a lot of resources to be used. I know a few questions came up about bolting flanges together, and there's a technical note in that. So yeah, a lot of different information. And again, you know, we're kind of running out of time here at the end, but if you have questions on these resources, looking for something you can't find, please contact one of us and we'll be happy to get that for you.
That being said, we're right at our time, and respect your time and your participation today. So thank you all so very much. And until the next time.
Thanks.